let's wait for a while. And the plot is here. I just need to put a line there. Okay, let's try to put the line in the plot. Lines, x, fresh w, y, fresh w. Let's use color equal blue. Let's use a line width equal to, I think it should go. Let's see. Okay, good. The only thing is that, let's try to expand it a little bit. And what can we see here? That the freshwater table is just above the seawater level, which is, fine. You may say, well, there is a very tiny difference between the two levels. Maybe that we have a quite pronounced wedge. Let's see. So we are at the start now. And now we have to apply this very simple relationship here. It's very easy. From a conceptual point of view, it's very easy. From a numerical point of view, I would like to make some consideration with you, some reflection. If I look at the plot above there, the situation is like this. We have a land profile, a ground profile, which is something like this, which is not the same. This is just an example. So it's a polyline, meaning a sequence of segments. This is perfect because in any case, when I need to make a survey of a profile, I need to discretize it, which means that I describe it by points, like I did here, and then between points I draw segments. This is piecewise linear interpolation. Piecewise linear interpolation. Which is fine, but it is clear that it's not realistic. Because the ground, actually, it's not a sequence of segments. But that's fine, okay. Especially if the points are many, if the spatial step is very small, that's fine. I cannot even see the difference. And then I have here a sea level, which is located like here. And I draw the dashed line here. And then I have a freshwater profile, which is again described by points through a piecewise linear interpolation, something like this. And actually what happens is that I have only 5 points to describe the freshwater level. You don't see here the segments because the scale is very compressed. But it's clear that if I draw a saltwater wedge there, what happens is that I will get a wedge that is something like this. I will find for the first point a depth, and for the second point another depth, and then something like this. This is what I am expecting, which is a sequence of 4 segments in order to describe the wedge. And this is, you know, something that probably needs to be refined, because I cannot describe a wedge which has a curvature. It's a curve, basically, through, and it's quite extended because it's extended 60 meters. The abscissa here is from the shoreline to the last point of my description. It's from 80 to 140, it's 60 meters. And if I describe it only with 5 points, the approximation is very rough. So my question is, why don't we try to interpolate it, to describe it with more points? And if I want to do this, I have to start from the freshwater level. A possibility is to start from here, interpolate the freshwater level, increase the number of points, and then for each interpolated points, each interpolated position of the freshwater level, I compute the position of the wedge. Is this clear to you what I suggest to do? And now you should also understand, when I was talking about abscissas before, when I introduced the theory just half an hour ago, I said for each abscissa, which is each x coordinate of these points, what I want to compute, I want to compute the ordinate, which is my capital H. I am also proposing to you to increase the number of points, because this is an opportunity to explore other possibilities that R gives us. So this is the reason why I am proposing to do this. And actually, what do I have to do? The first thing that I have to do is to increase the number of points here. So not to use only 5 points to describe the profiles from 80 to 140, but increase the number of points through linear interpolation. Okay? This increasing the number of points doesn't resolve the problem that I see angles in this profile. Because if I have one segment and then I split it in 100 segments through linear interpolation, what I see from a visual point of view is the same line, which is described by more points, but it's still the same line. I want to be clear. If I have a segment or let me say, if I have 2 segments, here and here, and this spike, this angle is not realistic, and I want to smooth it, so I want to obtain something like this, which is more realistic, I need 2 steps. The first step is to increase the number of points here. If I have only 3 points originally, let me increase the number of points through linear interpolation. In this way, I increase the number of points, but still I see 2 segments. And then I need to smooth the connection between these points. Smooth means that I need to, like smoothing, in Italian I would say lisciare the spike given by this angle. Okay, so let's make these 2 steps. In R it's very easy, because if you think about doing something like this in Excel, it's a bit complicated. In R it's very easy. So first I need to interpolate the freshwater profile. I have a look now at my code because I want to use the same procedure. Okay? Actually, we don't need to look at pre-prepared code, but I want to use the same procedure. So let me have a look at the code, just 1 second. And this is what I wanted to get. So let me clear the screen and let me show you this instruction. Okay, I take a temporary variable which I call PR1. You can set the name, whatever name you want. And then I use a function in R which is called approx. Approx means that gives to you the opportunity. You give points of a sequence of segments, and then approx increases the number of points through linear interpolation. Linear interpolation. So basically what it does is you give 3 points, 1, 2, 3. Approx connects these 3 points with 2 segments, and then gives back to you the coordinates of the number that you wish of intermediate points. You understand that it's very handy, it's very useful. You describe a figure by points, and approx refines the description through linear interpolation. And you have to specify either how many points you want in between, or you can specify the abscissas of the points that you want. So if you look at this instruction here, it says approx. First you have to give the x and y, the coordinates of the points that you want to interpolate. And you see that I am interpolating the freshwater profile. I am giving the x and y coordinates of the freshwater profile. And then I am specifying the out, x out, so the abscissas of the new points where I want to get my function interpolated. And you see that the abscissa is a sequence from 80 to 140, which covers the whole range of the freshwater profile, and with a step of 1. So I'm getting 1 point each meter. Very good. Let's press return. I don't understand this warning. It doesn't appear anymore. Okay. Very good. So this is, the graph is still there. This is the result of my approximation. And what is PR1? It's a list. If you look for the names of the variables in this list, they are x and y. Perfect. These are the coordinates of the new points. This is very useful. Actually, I used it in my activity several times. It's very useful. You give the coordinates of whatever function and you get a linear interpolation of it. It doesn't perform extrapolation. Let's forget about it for now. I just wanted to tell you. Okay, and now these new coordinates, we have to smooth them. Let me go back again to the code. there are several ways in R to smooth a series of points, to get a curve from a sequence of segments. And the easiest way, in my opinion, but you may find other solutions, is to use the function smooth spline. And again, you have to select an auxiliary variable, a temporary variable. Again, I use PR1. You have to give the coordinates of the points that you want to smooth. And I am smoothing PR1x and PR1y, which is the result of the interpolation. And spar is a smoothing parameter, S spar, which varies from 0, no smoothing, and 1, highest degree of smoothing. Good. And then we obtained our, if you look for names, again PR1, we obtained the new several things, but we are interested in X and Y.
Prof, what does the dollar symbol mean?
Dollar means, yeah, correct. I'm not sure whether I already introduced you lists in R. And lists are a way to group in one variable several different information. Like, let me make an example, and so let me clear the screen. And then I go back to the function with the dollars. So the list can be created by like temp equal list. And you may specify what you want in the list, like temp. But you have to give a name for the sub-variable. So a list, basically, is a variable which includes several sub-variables. And then you may write that temp x, and dollar is a way to say this is a name of a sub-variable. And it's equal to 2, for instance. And you may write temp dollar y is equal to 10. And then if you write temp, you get the sub-variables x and y. And you can also write a character like temp dollar name is equal to Alberto. And then if you digit temp, you have the two vectors, the two variables, sub-variables, and the name. Okay? This is basically and so let's go back to our instruction. Basically, when I asked for the names of PR1 previously, PR1 was this one, names of PR1. This instruction means give me the names of the variables in this list, and the names are x and y. So if you make now PR1 x, you see it's 80, 81, 82, etc. And then PR1 y, it's the linear interpolation. And then I performed the smoothing. Here it is. And what I am smoothing here, I am smoothing PR1x, PR1y with a smoothing parameter of 0.8. And then, if you make again PR1 x, now you see the same x, because what is smoothed is the y. And then PR1 y, you see that it's smoothed, you see that the number of digits is increased. Now, if we if you go and plot it on the original plot, which is this one, we don't see any difference because in the freshwater profile you don't see any difference because it's already very flat. But we will see the difference in the wedge. Now we have to compute the position of the wedge, and we have to compute it for each interpolated and smoothed position of the freshwater profile. And it is very simple, because we just need to do this. But remember what is h, lowercase h. Lowercase h is the difference between the freshwater profile and the seawater level. So what we have to do is very simple. We have to make capital H is equal to 40, which multiplies PR1 y minus 5.5. But H is a depth. If we want to measure it, if you want to draw it on the plot, we need to express it as a y, as an altitude. So I would say that we have to make H is equal to, let me think about it, so it's a depth, and therefore I need to make 5.5 minus H. This should work. And now we can plot it. Okay, now let's try to plot it. Plot. PR1 x dot h. I hope it works. No, not plot, sorry, lines. I would say that probably line width is equal to 2, and the color is equal to, let's use red again. Okay, let's see if I was successful. Yeah, perfect. This is our saltwater wedge. It is strange because it's red on my screen and here it's black, okay? Be patient. So at this stage we have to make some considerations. The first consideration is let's try to see what's the difference if we plot here the wedge without any interpolation, any smoothing. So let's see if indeed interpolating and smoothing allowed us to obtain a more realistic representation. This is the first consideration that I would like to make. So let's do this then. First, let's remember that we still have the coordinates of the freshwater profile, not interpolated. Sorry. These are the x and these are the y's. Good. So it's very simple to compute another capital H. So let's write capital H1 is equal to 40 times y fresh W minus 5.5. So I am repeating what I did before with the only difference that I am using only the 5 points. Okay? And then I can write again, sorry, H1 is equal to H1 or 5.5 minus H1. This is the position, the new wedge without interpolation. And let's try to superimpose it to the wedge that we already computed. So what we have to do is simply write lines again, X fresh W, H1, let me change the color, blue, and line type, LTY equal to, so it's dashed. And here is what I obtained. It's difficult to see the difference, but let me expand it a little bit. And you see that indeed, the smoothing was effective. You see that there are angles here in the blue line that I was able to smooth out